I like us better when we're wasted. It makes it easy.
Objective. This video has a purpose to explain the concept of hydrocarbons, as well as the steps and importances of naming them in a correct way, or according to UPAC. In this video, we will explain everything about hydrocarbons. It will be mentioned the rules and the importance of learning them, as well as their classifications and the main examples of them. We will look up on the structures of the functional rules and the steps to name them by the structure. We hope you understand really well and you enjoy this video. The International Union of Pure and Applied Chemistry, or UPAC, is an international federation of national authoring organizations that represents chemists in individual countries. It is a recognized world authority in developing standards for the naming of the chemical elements and compounds. Hydrocarbons, or compounds based on a change of hydrogen and carbon, are the basis of organic chemistry. You need to learn the name according to the UPAC, which is the currently accepted method for naming hydrocarbon chains. The main classification of hydrocarbons is the one based on the type of bonds involved in the structure. There are 4 types of hydrocarbons. These are the alkanes, which are saturated. This means that each carbon is bound to 4 other atoms through single covalent bonds. Hydrogen atoms usually occupy all available bonding positions after the carbons have bound each other. Others are the alkanes and the alkenes, which are unsaturated. By unsaturated, we mean that hydrocarbons contain either double or triple bonds. Since the compound is unsaturated with respect to hydrogen atoms, the extra electrons are shared between 2 carbon double or triple bonds. Aromatic compounds include only those with a benzene ring, which is a special 6-carbon ring compound with 3 alternating double bonds. These structures impart unique properties to benzene, which are different from other ring compounds. Hydrocarbon derivatives are formed when there is a substitution or a functional group at one or more of these positions.
An alkyne is an hydrocarbon containing only a single carbon-carbon bond. UPAC rule for alkanes. Step 1. Count the number of carbon atoms in the longest continuous chain. Step 2. Number each carbon in the parent chain. Locate the end carbon closest to a substituent group. Give all the substituent groups the lowest position numbers possible. Step 3. Name each alkyl group substituent. Place the name of the group before the name of the parent chain. Step 4. Use the same alkyl group occurs more than once as a branch in the parent structure. Use a prefix, D, 3, tetra, and so on, before its name to indicate how many times it appears. Then use the number of the carbon to which each is attached to indicate its position. Step 5. When different alkyl groups are attached to the same parent structure, place their names in alphabetical order. Do not consider the prefixes D, 3, and so on when determining alphabetical order. Step 6. Write the entire name, using hyphens to separate numbers from words, and commas to separate numbers.
With the previous UPAC rules for alkanes, we're going to solve this example, and we're going to get the name. Okay, first, we're going to count the number of carbon atoms in the longest continuous chain. There is 1, 2, 3, 4, 5. We're going to number each carbon atom, and depending on how closest the carbon atom is to a substituent. So this 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. It is the same if you number each carbon by the left to right and right to left, because it's going to be the same. So I'm going to do it from left to right. Okay? 1, 2, 3, 4, 5. Okay. Now we're going to get the alkyl group that is here, and here, and here. CH3 is methyl, so we're going to name the structure. The parent chain is 5, so it's contained. So we're going to write the name in alphabetical order, okay? So first is 1, first is 2, then 3, 4, 3, the prefix 3 because there are 3 methyls, and then 3 methyl, and then pentane because of the parent chain. Now we got the name, that is 2, 3, 4, 3-methylpentane. So here's another example to get the name of this alkane structure. First we're going to get the longest continuous chain, that is 1, 2, 3, 4, 5, 6. We're going to number each carbon in the parent chain. 1, 2, 3, 4, 5. Okay. Now we're going to name the alkyl group, that is here and here. Here is CH2, CH3, that is ethyl, and here is CH3, that is methyl. As I said before, we're going to name we're going to write the names in alphabetical order. So first is ethyl, and this is 3, ethyl, and then methyl, 2, methyl, and then the parent chain, that is hexane. After methyl we're going to write hexane. So the answer is 3-ethyl 2-methyl hexane. Here is another example. First we're going to count the number of carbon atoms in the longest continuous chain. So 1, 2, 3, 4, 5, 6, 7. We're going to name each carbon in the bond chain. 2, 3, 4, 5, 6, 7. The bond chain is 7, so it's going to be heptane. Okay. Then we're going to name each color with each of the group substitute. We're going to name each alkyl group, that is here and here is CH3, and CH3. No, here is CH3, CH, and CH3. This is isopropyl. And here is CH2, CH3, and this is H2.
Kills my heart to see.
We're going to write the name
It rises no longer in
So
me.
first is ethyl.
It's critical. about
The
me.
first is isopropyl.
You stop messing with me. It kills my heart to know
Isopropyl.
you don't think this love could grow. Cause anywhere you go,
And 4
you know I would follow. Cause I'm sleepless about you.
4 ethyl heptane.
Sleepless about you. Oh, oh, oh.
Now we got the name 3 isopropyl 4 ethyl heptane. Steps in the volcanic structure. Step 1. State how many hydrogens are attached. Step 2. Plot the number of hydrogens between bonds. Step 3. Depending on the constituent, state in which branch of the carbon atom the atomic group is. First, now the structural formula.
It's critical to
We
me.
need to get the
You stop messing with me. It kills my heart to know
chain is the
you don't think this love could grow.
We're going to draw
Cause anywhere you go,
carbon atoms.
you know I would follow. Cause I'm
There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then
my heart, you know,
we're going to draw
like no one ever did before. And I heard you moved on.
branch.
Yeah, I heard you
First
moved on. Cause I'm sleepless about you. Sleepless about you. Oh, oh,
then it says 3.
sleepless about you.
These are this is how you get the structural formula. And
Kiss my heart, you know, no one ever did before.
here is another example. For it to be far from the chain, we have to draw the small part chain that is octane. So we draw 8 carbon atoms. Okay. Now, depending on the constituent, we're going to draw the alkyl group branch. We're going to draw first metal. Here, as it says here, it says the methyls. There, it means that there are 2 methyls. There is one in the 3, and the 3 carbon atom, and in the 5 carbon atom. So, methyl is 3. And in the 5, 1, 2, 3, 4, 5. There is other. Okay. Then in the 4 carbon atom, there is one ethyl. Ethyl is CH2, CH3. Here is the structural formula for 4 ethyl 3, 5 dimethyloctane. Here we got another example. First, we need to get the parent chain, that is octane. We're going to draw 8 carbon atoms. Okay, 1, 2, 3, 4, 5, 6, 7. Depending on the substituent, we're going to draw the alkyl group branch. Here it says that here use the prefix 3, so there are 3 methyls, and there is 1 in 3, in 4, and 5 carbon. So 1, 2, 3. Here it says ethyl, so you can see H3, here in the form it says Now we got the structural formula 2, 3, 4, 5 triethyloctane.
What alkenes are? Alkenes are a type of hydrocarbon that contains double carbon bonds. The rules to name an alkene are the following ones. The parent chain must include the double bond. Number 2. The number of carbon from the ending closer to the double bond. 3. Indicate the location of double bond. 4. Change the ending for ane, in, and ine. To naming alkenes, when naming alkenes, the process is similar to alkene, except alkene substitutes the ending of ane and ane. Some examples are like this. For example, we first put the carbons that are 1, 2, 3, 4, 5 carbons. Then we fill it with the hydrogens in the missing places. When it's called alkene. Alkene is the ones that have double bonds. And then to name it, you have to know how many are. We put prefixes. One prefix is like pen, that is 5, and in, that is alkene. The other one is, for example, the second one is the same as the other one, but here it's in a chain 2, and we have to put pentane. Depending on what the number of carbons are released. To drawing alkenes, first to draw the carbon of the parent chain and number carbons and insert double bond. The second one is draw in alkyl groups. The third is fill in hydrogen, so every carbon has 4 bonds. As a reminder that double bond count as 2 bonds. For example, first the structural formula of 1-butene, we have to put the carbons that are 4 because butene is 4. Draw the alkyl groups. Then the structural formula will be H2C, double bond, CH, 1 bond, CH2, 1 bond, CH3. Another
Alkynes are unsaturated hydrocarbons with 1 or more triple carbon-to-carbon bonds. The steps to name the U-pack in the compound are: first, identify the longest carbon chain, then identify all of the substituents, then number of carbons, and if the same substituents occurs more than once, we use D, 3 or tetra, or depending on the number of carbons. Write it in alphabetical order, and also a cyclic is designed
by the prefix cycle. So as I say, alkynes are unsaturated hydrocarbons with one or more triple carbon to carbon bond. The general formula is this one. And in naming alkynes, we use the prefix YNE. And if heat is condensed, expand the structure, then find the longest chain that contains a triple bond, number the carbons, and the name parent chain ending always with YNE. And we have to write it also in alphabetical order, and all these are steps of naming alkynes. In here I have an example. So this is a triple, so it's an alkyne. This is a straight chain alkyne, so we need to shape it. And we have to find the longest chain. So this compound is 2-pentane. And in here there is another example.
The aromatic compounds are hydrocarbons derived from petroleum, characterized by the ring-like molecular structure and sweet or aromatic odor. Benzene, toluene, and xylene are the most common aromatics and are used as a chemical feedstock, solvents, and additives to gasoline to raise its octane rating. Naming aromatics with one substituent. No numbers are needed. We only put the substituent plus benzene, and some of these compounds has a common name. Here we have an example of an aromatic with only one substituent. Here we can observe that the parent chain is here, the one with the benzene, and our substituent is here. Okay, the name of this parent chain is benzene. Now we have to put the name for our substituent. They have 1 and 2 carbons, so it will be an ethyl. Now we have to name the whole complete compound. The name of this compound will be ethyl benzene. Naming compounds with two substituents. We only use numbers or prefixes plus the substituent in alphabetical order plus benzene. The prefixes we have is ortho, when the carbon is located in the one and the second carbon, meta for the first and the third, and para for the first and the fourth. We can also use only the first word, the first letter of each word. Here we have an example of an aromatic with two substituents, 1 and 2. Okay, our parent chain is the benzene here. And now we're going to name our substituents. This is a bromide and a chloride. Okay, we have to number each one. 1, 2. And now we're going to put by alphabetical order. We have first bromide. We have 1 bromide, 2 chloride, benzene. Or we can also put a prefix. The prefixes we have is ortho, meta, and para. So we're going to use ortho, and I'm going to put only the O. The ortho is for 1 and 2. So it's ortho. Bromine. Chlorine. Benzene. So here we have the two names of our compound. When naming components with 3 or more substituents, we don't use prefixes, we use only numbers, and the compound has to be in alphabetical order. Here we have an example of an aromatic of 3 substituents. We have here 1, 2, and 3. Okay, now the first step is for naming it. It's putting the numbers. We have here 1, 2, and 4. Now we have to name each substituent. The first one, it's only 1 carbon, so it's methyl. The second one has 2 carbons, so it's ethyl. And the third one has 3 carbons, so it is propyl. Okay, now we have to put it in alphabetical order. We have first ethyl, we put 2, ethyl, then we have methyl, 1, methyl, then we have propyl, it's 4, propyl, benzene. So here we have the number.